All right, want to give you as much time as possible today to work on the assignment that you have in front of you. All right, so this will be your kind of last or summative assessment on Newton's second law. All right, there's nothing on this sheet we haven't done, at least a few examples of each. Some of these we've probably done 8 or 9 examples of already. Okay, so there shouldn't be anything on there that's completely alien, but maybe the way it's written is a little unfamiliar. So I'm just going to quickly go through a few of the questions that might seem a little bit weird in their wording, just so you know what's going on. Okay, so for question number 1, don't overthink that. Okay, it's really quite straightforward. It's like one of the easiest ones we did on the very first day. All right, I'm giving you the acceleration and the mass and asking you to calculate the force. Just remember this for this question and for many of the questions. Force, acceleration are both vector quantities. Make sure you put vectors on those quantities. Okay? There could be a variety of vectors that could be useful for question number 1. Okay? All right, question number 2, also one you don't need to overthink. Okay, it's 2 steps, but it's not terribly difficult. Okay, you're just looking for the force, the net force that's acting on the Porsche. Okay, number 3, okay, you got a force vector that's basic. This one's just asking you to find the vector components. Like that one could have been on your vector assignment from last unit, and you would have had no problem with it. Just find x and y. Okay, question number 3. Question number 4 throws people. Okay, so I need you paying close attention here. What you are looking for is to find the acceleration of this box in each of these situations. So in situation A, situation B, and situation C. They have given you the free body diagram. All right, we know the mass of this thing is 5 kilograms, and they're telling you here are the forces acting on that mass. You need to calculate the acceleration of that mass. So you probably need to draw another diagram. Okay, well, maybe not for C because it's collinear, but okay, for the other 2, right? So you can get the net force and so on. All right, so just know they've given you the free body diagrams here, and this is 3 separate questions. Okay, calculate the acceleration in part A, magnitude and direction, okay, and B and C. All right, 5 is a little bit tricky. Okay, in number 5, we're looking for one of the forces that's acting on the object. We've got the mass and we've got the acceleration, okay, as well as the vector for the acceleration. So there's something we can get with those 2 things, and then we know one of the forces that's acting on this box, okay? So what we're trying to, or so on this sphere, sorry. What we're trying to do is find out what the missing force is. So this is vector related. Okay, you have the ability to get the resultant of the 2 vectors. You're going to have to find one of the 2 vectors involved. Okay, what I will tell you is this. The missing vector is not vertical. People make that assumption and it's not correct. Okay, what we have is that we can find, okay, the net force. We know one of the 2 forces that is contributing to that net force, and we're trying to find the other force, and it's not vertical. Okay? It's angled. All right, for number 6, this is another one people really overthink. Okay? This spacecraft has 4 engines. You can only fire 1 engine at a time. Okay? You can't fire 2 at once, just 1 at a time. Each engine can exert 68,000 newtons worth of force, and the mass of the ship is 4,160 kilograms or something. You can get with those 2 numbers. That's really important for this question. Okay? The ship is initially traveling to the right at 2,170 meters per second. We don't want to do that anymore. We want to go this way at twice that velocity. So you need to tell me which engines you need to fire and how long in seconds you need to fire each one for. All right, so it's 2 steps. You have to stop the spacecraft, and then you have to make it go the other way until it's going twice as fast as it was initially going. All right, so 2 steps there. The other hint I'll give you is that this has no like really difficult math in it. Okay, there's like 2 calculations and really that's it. All right, number 7 we've done. Number 7 and number 8 we've done a whole bunch like these. Okay, we call these static condition examples. Okay, we've done a bunch like that where the object's not moving, but there's forces acting on it anyway. And in fact, we have done both of these questions. Okay, there are examples that are identical literally to these 2 questions somewhere, okay, that we have done. Okay, number 9, this is the one like what we did yesterday with friction and the box being pulled at an angle. Okay, the box isn't moving at an angle, but it's being pulled at an angle. Okay, so friction's involved, vectors are involved. This is probably the mother of all questions on this particular assignment, right? It's the most involved, has the most to do, okay? 10 and 11 are both inclined plane questions. Now, the way they word this is weird. When they ask you to compute the component of gravitational force acting down the plane, they are wanting you to compute F parallel. That's what that is. F parallel is the component of gravity acting down the plane. Okay, I've used that term a few times before, but just in case you've forgotten, that's what they're asking. So for part A on number 11 as well, okay, the trunk's weight parallel to the plane, again, that's F parallel, okay, because weight is the force of gravity. All right, that's all I've got to say on that. Okay, I can't remember what day I made this due, but I'll get back to you on that. Okay, you guys can get started for it. So this will be due on November 4th. Okay, it's next week. Right, that gives you time to come in, see me, and get it done and whatever else. Okay?